Hello everyone, my name is Nikita and I am from the Bodhi Academy. In the previous video, we had started with the lesson Acid, Bases and Salts from the 10th Standard Science textbook, and we had covered some introductory concepts. Today we are going to move on further with the lesson, and we will see some more concepts about the acids and bases. Okay, now when now there's an to study this important part, there is an activity in the textbook. Okay, the subtopic for this is acids and bases. What do they have in common? Okay, what do they contain in common? Okay, especially the acids. For this we will see the activity. In this activity, the different solutions were taken. For example, glucose, alcohol, okay, then acetic acid, hydrochloric acid, sulfuric acid. These solutions were taken in a beaker, and there was conduction of electricity. Okay, electricity was passed. Two iron nails were placed over here and it was connected to an electric circuit, and there was a bulb for detection of electricity. So the main purpose of this activity was to know which solution will be able to conduct electricity. Okay, which solution will be responsible for the conduction of electricity. So when the solution such as glucose and alcohol was taken, the bulb did not glow. Okay, this bulb did not glow. This bulb did not glow. This showed that there was no conduction of electricity when solutions like glucose and alcohol were taken. But in case of all the acids, such that the sulfuric acid, the hydrochloric acid, the nitric acid, the acetic acid, there was conduction of electricity and the bulb blew at this time. The bulb glowed. So now what do we conclude from this? So it was concluded from this that first of all we have studied in the electricity chapter that for conduction of electricity there should be movement of charges. Okay, and for the liquids to conduct electricity, okay, there should be movement of ions. Okay, there should be free movement of ions. If there is free movement of ions, then only the electricity will be conducted. So there should be the presence of ions and there should be free movement of the ions. Now in the case of glucose and alcohol, both these are organic solutions. Okay, organic solutions, and there were no ions. In this case there were no ions, therefore there was no conduction of electricity. But in case of acids such as HCl, HNO3, H2SO4 and acetic acid, that is CH3COOH. Okay, all this, there was this acid split into the ions, that is all of this acid split into the cation, that is H plus ion, and the respective anions. For example, HCl will be split into H plus and Cl minus ion. Again over here it will be H plus and NO3 minus ion. Here over here it will be H plus and SO4 minus ion. So over here also it will be H plus and CH3COO minus ion. So you can observe that in all the cases what is common is the H plus ion, the cation. Okay, H plus ion is common in all the acids. Okay, it is common, and these ions are responsible for the conduction of electricity. Therefore the organic solutions such as glucose and alcohol were not able to conduct electricity because there was no presence of ions. But in case of acids, the acids split into cations and anions, which are responsible for the conduction of electricity, and that's the reason the bulb glowed. Okay, now So what do the acids have in common is the H plus ion. Okay. Now to understand the other concept, we need to see another activity. Okay. In this activity, first of all, we need to see what are they adding in the test tube. Okay. In this test tube, dry NaCl, okay, 1 gram of NaCl was added, 1 gram of NaCl was added, okay, and concentrated sulfuric acid. So two things were added, NaCl plus H2SO4, okay, this was added. Now this reaction leads to the formation of HCl but in gaseous form. Okay, so this leads to the formation of HCl but in the gaseous form. Now this gas which was produced over here was passed on. Now this gas had to be tested. So the experiment, the people wanted to test the gas which was produced, whether it is actually HCl or no. Now we know that HCl is an acid. So the litmus paper which was used over here was blue litmus paper, okay, as an indicator. Now in case of acids, the blue litmus paper would turn to red. So the gas was passed through a delivery tube and here it was tested. Now in the first case, they used a dry litmus paper. Okay, a dry litmus paper was used. When when the blue color dry litmus paper was used, there was no color change. Okay, there was no color change. So the scientists were confused because HCl gas has to be produced over here. Okay, and if HCl gas has to be produced, then definitely there should be color change from blue to red. But in this case, in the dry litmus paper, there was no color change from blue to red. So what could be the reason? Then they tried moistening the litmus paper. Okay, they wetted the litmus paper and they used for testing. Now, while using the wet litmus paper, the color changed from blue to red. Okay, this now what can you conclude from this? What can you conclude from this is that acids show their acidic properties only in aqueous form. Okay. Now it was HCl gas which was produced, right? It was dry. Then you expose it to dry litmus paper which was blue in color. There was no color change. No color change. But in the second case, what do? We use a wet litmus paper. Okay. In this case, the color changed to red. Okay. Now, this was dry HCl gas. What if you had to take the what if you had to moisten the gas? Okay, that time also the color change would be blue to red. So these cases indicate that for showing its acidic properties, the acid should be in aqueous form. Okay. Now we have seen two cases. In the first case, the H plus ion. Okay, the H plus ion is responsible for the conduction of electricity. Okay, that is one property of the acids. And in the second case, it requires water. So we conclude that the H plus ions which are present in the acid can exit only in the presence of water. Okay. The H plus ions which are present in the acids can exist only in the presence of water. They cannot exist alone. Okay, they cannot exist alone means they cannot show their acidic properties without water. Okay, they always combine with the water and they are shown as H3O plus ions or hydronium ions. These are called as hydronium ions. Okay, so acids show their acidic properties only in the presence of water or only in the aqueous state, because the H plus ions can exist only in the presence of water and they exist as H3O plus ions. Okay, so this is what the acids have in common. Now what do the bases have in common? Okay, the bases have OH minus ions which are called as hydroxyl ions. So H plus are called as hydronium ions which exist as H3O plus, and the OH minus ions are called as hydroxyl ions which are present in the bases. Now when we talk about addition of water in the acid, okay, addition of water in the acid. Okay, now the mixing of the process of mixing of an water and acid, okay, is a very exothermic reaction. Okay, very exothermic reactions. Care has to be taken when you do this process, and it is always advised to add acid to water, okay, and not water to acid. This is wrong. This is a big danger sign. Okay, this is a big danger sign. You should never add water to acid. Okay, always acid should be added to water. Means you take the water first, whatever quantity it is, and you have to always do that process very slowly. Means you have to add acid to water, acid in the water very slowly with constant stirring. Okay, with constant stirring. If by mistake you add water to acid, then this reaction is very exothermic reaction. Okay, and will lead to the mixture splashing out of the beaker. The beaker will break. It will lead to the mixture splashing out of the beaker and you may get very harmful burns. So to avoid all this, you have to always add acid to water and not water to acid. Okay. This is a very common question which is asked in the Goa board exams, that why it is always advised to add acid to water and not water to acid. Okay. So now we have already seen the indicators, okay, that natural indicators and synthetic indicators which are used to indicate the acidity or the acid and basic nature of a material. Okay, now to actually see the concentration of the acid or to actually determine the acidity and the basicity of a particular substance, of all the substances, okay, of all the substances, and to determine what actually would be the acid, okay, what actually would be the nature of a substance, at what concentration, we have something called as an universal indicator. Okay, universal indicator means the one which will be able to determine the concentration of H plus and OH minus ions. Now depending upon the H plus and OH minus ions, okay, the acidity and the basicity is given a pH scale. Okay, it is given a scale from 0 to 14. Okay, depending upon the concentration of H plus and OH minus ion of acid and bases respectively. The scale is given a range from 0 to 40, and this scale is called as the pH scale. Okay, it is the universal indicator which is used to indicate the nature of any material from 0 to 14 range. Now pH, P stands for Pons, which means power of hydrogen. Okay, power of hydrogen. Now the scale is divided from 0 to 6. Okay, from 0 to 6 and then 8 to 14. 0 to 6 it is for acidic properties and 8 to 14 is for basic properties. Okay, and what is remaining is 7. 7 is for neutral, which is neither basic nor acidic, it is in between. Okay, now how do we read this? Okay, so this is a pH scale from 0 to 14. Okay, 0 to 7 we have increase in, we have the hydrogen concentration. Okay, from 0 to 14. Okay, now what exactly happens over here is that from 0 to 7 we have the acids. Okay, but the acidic nature increases, okay, towards this side. Okay, it increases towards the lower side. Okay, so as you go from 7 to 0, the acidic nature will increase. Okay, the pH 6 acid will be of low strength. Okay, pH 5 will be a stronger than pH 6, and pH 4 will be again stronger than pH 5. pH 3 will be stronger than pH 4. So as the pH decreases, the acidic nature is increasing, which means that hydrogen ion concentration is increasing. Okay, so how it is? If as the pH decreases, okay, from 7 to 0, the H plus ion concentration, it increases and the acidic nature also increases. Okay, yes. Then we have the other side, 7 to 14. From 7 to 14 the basic nature increases. Okay, as you go from 7 to 14, as the pH number increases from 7 to 14, there is increase in OH minus ion concentration, increase in basic nature, and there is decrease in H plus ions. Okay, so over here, over this side there is increase in H plus ions, and over the other side there is decrease in H plus ions, and there is increase in OH minus ions. Okay, so as the pH increases from 8 to 14, there is H plus ions concentration decreases. Okay, OH minus ion concentration increase, and also basic nature increases. Okay, so this is all what we need to know about the universal indicator, which is pH, which has the scale from 0 to 14. Okay, 0 to 6 we have acidic nature, and acidic nature increases as you go from 7 to 0. Okay, the opposite side. Then over there also the H plus ion concentration increases and acidic nature increases. Okay, but when you go from 8 to 14, the H plus ion concentration tends to decrease. As H plus concentration decreases, the OH minus concentration increases. And when OH minus concentration increases, the basic nature of the basic nature increases. Okay, in the indicator increase. Now, what about pH 7? In this pH, the pH 7, it is for neutral, which is neither acidic nor basic. Okay. So, we have covered the concepts of acidic and basic substances. In the next video, we will be doing all about salts. Okay. About common salts, the application of common salts. So, thank you for watching my video. Please like, share and subscribe to our channel.